This problem and all other Calc 152 problems can be found here at Sarai Studies. A link is in the description box below. Hey, so we're going to do an integration by parts problem. Let's get started. So we have the integral of arctangent. Let's first write down the formulas where the v's are on the inside. We know that this is our answer, but we need the component. So let's actually go in order. So we have u and v. I want to just du, dv. I have to find my u first, and I use limit to do so. So limit, I look at this and I ask, do I see any logs? No. Do I see any inverse trig? Yes. So I'm going to make my inverse trig with u. And then whatever is left, which is just 1 times this. So whatever's left, what the x that becomes your AB. And then integration by parts, you always have to do 2 integrals. So I'm going to do a box and I'm going to cut it into 2. The first integral is to find v, which is the integral of dv, and we know dv is equal to 1 dx, and we know that the integral of a constant is just a variable, so x and then plus c because it's indefinite integral. But in integration by parts, if it's indefinite, we know that our final answer is going to just have 1 plus c, so we don't really care about the plus c's throughout the process. So we're just going to take x and cut that b there. And then du is a derivative of this. This is something you would have to memorize. I do have a video, and I will link it in the description box below on how to remember the derivative without memorizing. So basically, the derivative of arctan, that's just a different way of writing it, is a fraction, and then the derivative on the top, and then 1 plus. I like to think of it as a t, as a but, so it's a plus, and then the x squared. So whatever this is, it's derivative at the top, and then x squared at the bottom. And since this is just what it is, the derivative of this particularly is just 1, and then at the bottom we just have that being squared, and we do. So that's our derivative. So that's what's going to be du, and then don't forget the dx. Now we have all of the components that we need to plug it into our formula. So we have u, which is tan inverse. Then we have times v, which is x, minus the integral of v again, which is just x, and then times du, which is this over here. And then this is our du right here. Now, this is what I'm talking about. This is the second integral that we have to work on in our problem. So what I like to do is I like to drop everything down first. And then this here, whatever I get for this, is going to be in there. And then plus c, because it's an indefinite integral, so my bottom is just going to have a plus c. So I go and do this integral right here. So it's the integral of x times 1 over 1 plus x squared dx. I look at this and I say, okay, let me try a u substitution. So then I'm like, so c is what we care about. I care about my u, my du, my dx, make my denominator my u. Derivative is 2x times dx. And then dx is just take this and solve for dx. So it's really just always going to be du divided by whatever is next to it. And then our u part is to put everything in terms of u. So we take this x, this is u, and then dx is equal to du divided by 2x. And then these cancel out. And then you're just left with this 2 at the bottom, which you can bring out 1/2. And then you're just left with taking the integral of that. And we know that's ln of u, and then times 1/2 plus c. Our last part in Calc is to plug our u back in, because we need to have this in terms of your original variable x. So it's 1 ln, and then our u is 1 plus x squared, and then we have c. So this is our answer, but again, we always plug in everything that's not c into there, so then we already have 1 plus c. So it's going to be 1/2, and then ln of 1 plus x squared, and then this here, this entire thing is my final answer. So all you really have to know, oh my god, okay. So all you really have to know is really just this derivative, which again, I'll link a video in the description to show you how I remember it without really memorizing it. And that's really it for this video. I'll see you in the next. Bye.